Chapter 1. Isaac Newton, the man who measured the heavens and moved the earth. The 17th century in England was a time of war, plague, superstition, and religious strife. But from the ashes of chaos rose a mind that would forever alter the course of human understanding: Isaac Newton. Often called the father of modern physics, Newton was more than just the man who discovered gravity. He built a framework through which humanity could begin to decode the laws of the universe itself. Early life and a birth in chaos. Isaac Newton was born prematurely on December 25, 1642, in the tiny village of Woolsthorpe, Lincolnshire, England. His birth was so premature and fragile that no one expected him to survive. His father, also named Isaac Newton, had died 3 months earlier. His mother, Hannah Ayscough Newton, later remarried and left young Isaac in the care of his grandmother, a decision that may have shaped much of his solitary and secretive character. Newton's early schooling was uninspired. He was often distracted, more fascinated by constructing mechanical devices than rote memorization. However, once sent to the King's School in Grantham, his intellectual brilliance began to show. A chance encounter with books on astrology and alchemy awakened a deep curiosity about the natural world. Education at Cambridge and the Black Plague's silver lining. In 1661, Newton entered Trinity College, Cambridge, initially as a sub-Caesar, a student who performed menial duties to pay for education. At the time, university education was dominated by Aristotelian philosophy, which Newton would later help dismantle. A turning point came in 1665, when the Great Plague forced the university to shut down. Newton returned to Woolsthorpe, where in just 18 months of isolation he developed the foundations of calculus, formulated the laws of motion, and conceptualized the law of universal gravitation. He was just 23 years old. Later, he referred to this period as the annus mirabilis, his miraculous year. If I have seen further, it is by standing on the shoulders of giants. Isaac Newton, the apple that fell, and the law that rose. The famous tale of Newton observing an apple falling from a tree is not entirely myth. According to friends and later biographers, Newton did indeed draw inspiration from such a moment, wondering whether the same force that made the apple fall also governed the moon's motion. From this came his law of universal gravitation. Every mass attracts every other mass in the universe with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. This idea wasn't just about falling apples, it suggested that the universe was governed by predictable laws, the same on Earth as in the heavens. It was a profound philosophical shift, dismantling centuries of mysticism about celestial bodies. Laws of motion, the backbone of physics. In 1687, Newton published his magnum opus, Philosophia Naturalis Principia Mathematica, commonly known as Principia. In it, he outlined the 3 laws of motion, which became the foundation of classical mechanics. Inertia: a body remains at rest or in motion unless acted upon by an external force. F equals ma, force equals mass times acceleration. The rate of change of momentum is proportional to the force applied. Action-reaction: for every action, there is an equal and opposite reaction. These laws still form the foundation of engineering, astrophysics, and every branch of science that deals with motion. A mind of contradictions. Newton was not only a physicist, he was also obsessed with alchemy, biblical chronology, and occult studies. In fact, more than half of his writings were devoted to theology and alchemical experiments. He believed that secret knowledge of the cosmos was hidden in ancient texts and symbols. Few know that Newton also tried to predict the end of the world based on biblical numerology, placing the date around 2060. Despite his deep religiosity, Newton despised the idea of the Trinity, which led him to hide some of his theological views for fear of persecution. Scientific battles and a difficult temperament. Newton was known for being vindictive, secretive, and intolerant of criticism. He clashed famously with Robert Hooke, who accused Newton of plagiarism over optics; Gottfried Wilhelm Leibniz, with whom he had a bitter dispute over who invented calculus first; John Flamsteed, the astronomer royal, whose data Newton used without permission. When Newton became president of the Royal Society in 1703, he used his position to settle scores and exert control. Despite his personal failings, his influence on British science institutions was monumental. Other inventions and discoveries. Reflecting telescope. To overcome chromatic aberration in refracting telescopes, Newton designed a telescope using mirrors, a design still in use today. Calculus independently developed his own system of calculus, which he called the method of fluxions. Optics proved that white light was composed of a spectrum of colors and invented the color wheel. Unknown and fascinating facts. Newton never married and likely died a virgin. He once poked a needle in his eye to study optics. He wrote over 1 million words on theology and alchemy, more than on physics and mathematics combined. He resigned from academia to become warden and then master of the Royal Mint, where he personally oversaw the prosecution of counterfeiters. He was knighted by Queen Anne in 1705, not for his science, but for political loyalty. Death and legacy. Newton died in his sleep in 1727 at the age of 84. He was buried in Westminster Abbey, an honor few scientists have received. He left behind a new world, not in the metaphysical sense, but in the very way humans perceived nature. After Newton, the universe was no longer a mystery of divine whims, but a system of laws, measurable and discoverable. Why Newton still matters. Every rocket launch, every engineered structure, every orbital satellite carries within it the fingerprint of Newton's genius. His work gave birth to modern engineering, celestial mechanics, and much of applied physics. Even in modern physics, where Einstein's relativity and quantum mechanics rule, Newton's laws are still accurate enough to navigate space missions.